Okay, we're talking about some sample problems from your section 1.1 homework. And so we're solving linear equations now using the distributive property a lot. So on this example number 10, we're going to distribute the negative 9. Notice that's what's directly in front of the parenthesis and needs to be distributed. This 7x and positive 5 should be just brought down. Then the negative 9x distributes. Notice the negative distributes as well, making negative 9x and negative 9. Then you should always combine any like terms on either side. So 7 and minus 9 are like terms, and they're on the same side, so you're not changing any signs. 5 and minus 9 is negative 4. On the other side, nothing really combines, so we bring that down. Then we need our variables consolidated, brought to the same side. So I'd say this 2x, negative 2x, I'm going to bring it over, make it a positive 2x for a total of 7x's. And this positive 2 over to the left side, making it a minus 2. Negative 4 minus 2 is negative 6. Bring down your equal sign. Divide by what's by your variable, so we divide out the 7. 7 over 7 is 1x, that x we're always looking for an answer of negative 6/7 that we type in. Okay, our next example has decimals. So you could just work with the decimals. A lot of my students tell me they don't mind the decimals. They would leave those in order. It's fine. Also go through a technique where you clear the decimal if you want to, because you'll see them technique. So notice I only need one decimal point in each of these. This one doesn't really have a decimal except at the end, but whatever I decide to do, I have to do it to every term equally, kind of like timesing by the LCD like we did before. So I would say if I multiply by 10, it would move my decimal point one place. If you multiply by 100, it moves the decimal point 2 places, and so on. But multiplying by 10, 1 0 in it, moves it 1 decimal point. And that's really all I need for any of these terms now. You go by whatever you need, the biggest amount you need, which is 10 in this case. All right, so timesing by 10, and I distribute that, moves this decimal point and makes it a 7 point, or just 7x. It moves this decimal point, making that a 1. And it moves this decimal point one place. And even though this one doesn't look like it needs it, you have to do the same to all. So move it 1 decimal place, making it a 30. And then proceed as before. So I'm going to bring my 6x to the left. 7 minus 6 is 1x. Bring my minus 1 to the right, making it plus 1, and there's my answer. X is 31. So you might find that a handy trick to clear your decimals before you start working. Just make sure whatever you decide you need to do, you do it the same, a decimal amount to each term to keep it balanced. Lots of problems, huh? Okay, on this one, we get to practice it again. This time you can see I need 2 decimal places. So I need to times by 100 to move that one. No decimal in that, but whatever you do, you have to do it equally across the board. So I'm going to times each side of this equation by 100. So timesing by 100 on this first term makes that an 18y. Now, you may question what's a term, and all of this actually counts as being one term because that parenthesis is multiplied onto that. Whatever is multiplied together as one string amount, that term, that's an individual term. So when I multiply by 100, I only have to times the front part of that, and it affects the whole term. So move that over to a 6. Don't bother the parenthesis since it's times onto that. That will affect it. Now on this side, there's another term. The decimal's at the end, so moving it 2 places makes 960 and 2 extra zeros times by 100. And now we can proceed without those pesky decimals. I don't know. Like I said, some students just leave the decimals in it. They don't bother you too. They're not like fractions. They're not quite as bothersome. So that's kind of up to you. If you want to leave the decimals in it, that's fine too. You get the same answer. 18 and 6 are like terms, making 24y. And bring the other terms down. Bring the 24,000 across the line. Kind of one of the negatives of clearing the decimals is sometimes you do create larger numbers to deal with. So that could be a minus there. But anyway, that gives, what did I do? I was supposed to subtract. Sorry about that. So I was right in the first place. It was a minus 24,000, which made 72,000. Then last step is divide by what's on your variable. 24 divided by 24 makes 1y, or y. And then I need my calculator for that one. I think it's going to be 3,000, but I'm going to type that in just to be on the safe side. So I'm going to type in 72,000 divided by my 24, and there it is, 3,000, which then we could check if you wanted to. Okay, next example. Bring down the left side. Here we distribute the 2, making 6x and 8. Combine any like terms on either side. So maybe I meant to have an x there, I don't know. So 6x plus 7, and bring the variables together, minus 6x, and add the 7. X is 14. I'm questioning whether I wrote that problem right from your sample problems. Let's look real quick so I can tell you for sure. I'm trying to give similar to what's in your homework, and I was thinking there was a little something different about that, so hang with me for just a minute. Maybe not though. I mean, this problem is work if that be the original problem, but I'm thinking the original problem had maybe an x right there. Oh, my computer's not responding quickly. Well, anyway, if you get into your homework and see that it's a little bit different, and you have any questions with anything that you do, always feel free to send me an email and let me add any problems that you need, or we can Zoom together if you want to work some problems together. Always know that's an option. Okay, I'm going to move on to 14. I may come back to that if I see something different, but okay, on this one I'm distributing the 16. Here I'm distributing the 4. All right, this one's going to be special. I can kind of see ahead. That's why I was questioning if that was a special case. But can you see the 16v and the minus 4v makes 12v, and then I bring down the plus 16. On this side, I also have a 12v, and 8 and minus 12 is minus 4. So that's how I know something's up with this. I can't take 12 times whatever v is and add 16 and get the same thing as 12 times that same value for v and subtract 4. That's just not going to work out. Well, if we continue our process, I bring the 12 across the line. You see the v's cancel out. It's not 1v. There's no v's left. That would be 0v, which is 0 times anything is just 0. So there's no v left. The variable dropped out. And what you've got is 16 equals negative 4, which is kind of a nonsense or just untrue false statement. So that means there was no solution to that. It's just a flawed equation, you might say. Nothing would work for v. There's no solution. And in our first video, we call that a contradiction. Ask words for that when there's no solution to it. It's the empty set, and it's a contradiction. Okay. So after that, we move on to these solving for a specified variable. This is at the end of your homework in 1.1, and they have too many variables, so we're not really solving like d equals 2, but we're getting it in terms of d, the d alone, and kind of we're using it exactly same steps in these former equations, but they don't clean up, as tidy to just give you one number answer. But they're still the same rules. So what we say, if we're solving for d, we locate our d term, that's this term, and then anything that doesn't have a d in it, we'd consider the constant and throw it to the other side. So this positive term here, we throw to the opposite side. So we're trying to isolate our d variable. So if there would be two d variables, we'd want both of those on the same side, but we just have the one term that has d in it, you notice. Okay, so we've got that thrown across, making it minus, and I couldn't really combine those like I can sometimes. Like if I have 3 plus 4, I add those, but these are not like terms, so I just let it sit there. Then all of these are multipliers on that d, so the way we take care of that is we divide by each multiplier, divide the v, divide the pi, divide the 6, and then there's that 1d, solve for. Whatever I do to one side, I have to do to the other side. And that's really all we can do to that. That answer is fine as it is. You might question, can't we make that look any better? And you could say it's another option would be it's this s over 6 pi v, and then it's this over this, which a lot of that would cancel, and you just have a v. That is also equally correct if you wondered, but this is just as good, and you can just stop there. Okay, our next example, we're solving for L. Now notice this time there's two terms. There's 4 total terms, but there's 2 terms that contain L, the variable we want. So we want to keep those together on the same side. So this is the one that does not fit in. It's like a constant. We take it to the other side and make it minus 2WH. Okay, so we've got our L terms together and anything else to the side. If we could, we would combine these, but they're not like, so we can't. So here's a big the strategy. You're trying to solve for a variable and it's in more than one term, you have to factor that variable out. If you can't combine them, we factor. So we bring 2 and the w out. Then we factor it out of this side and we bring the 5 and the h out. So you factor out that common variable. And that will allow us to get the L by itself. That's always the goal. L equals or X equals whatever variable you're solving for. Well, this is times. You know, when you factor something out, that's a multiplier. So we can divide out this parenthesis to each side. You know, anything divided by itself, cancel away. Do the same thing on this side. And that's how we can leave that answer. L equals all of that mess. And that is following the rules, even though it kind of looks like a mess, that is the correct answer. Okay, number 17, another example. Solving for the x. So I see x's in 2 places. This x is sort of trapped though, so we need to get it out of that parenthesis by distributing. Release the x, right? So bring it out by distributing. Then consolidate your x terms. So I want to bring this x over with the other x, make it a minus 4x. Luckily, those combine though. 5x and minus 4x, I like that. I can combine that to be 1x. This a though needs to go to the opposite side, making it a minus a. And it does have a buddy, combine like terms. Negative 4a and negative a is negative 5a, and then the 4b is sitting there. And then that one is actually solved for without having to factor, because I was lucky that the x's were like terms on that one. And you can write it as negative 5a plus 4b or 4b minus 5a. The other one is equally correct. On number 18, I would start by getting rid of that fraction. If you see a fraction, clear fraction, I would put that over 1. You could times through by this is your LCD, or you could say this is a proportion, so I can cross multiply. So x times 1 equals x. And then a minus 4 times ax plus 6. I'm going to have to FOIL all that out. Out of these parentheses. So first is a x. Outer is 6a. Inner minus 4ax. And last times last is negative 24. I assume I'm solving for x here. I didn't know. I think it's solving for x. So I 3x terms, and you always want them to the same side. So this x on the list crosses over, making it negative. Oops, what did I write? It was a squared x. Sorry about that. And then this x crosses over, making it plus 4ax. And then what's left? 6a minus 24. Now remember the trick we learned earlier is you factor out the variable that you're solving for. If it's in more than one place and you can't combine, you factor. So we factor out the x. Now it does leave a 1. You need that 1 to hold the place, so don't forget that. Then you got an a squared, and then you got a 4a equals all this other side. Once you get this factoring done, all of this is your multiplier. So we divide the same thing, that set, divide it, and we're allowed to do that, and that will give us our x equals, And then that's our final answer. You might be able to factor. This one looks like one that might reduce. So I would try it, to see if anything might unfoil. I don't think it does. I'll double check that answer on that. But you should always see, can I factor? And you can factor out a 6 out of the top. And this looks like something that might do the reverse of the FOIL method. But I don't think it gives you any common values that will reduce. So I'm thinking we should stop there. And that's your final answer. I'll double check that in your homework though for you. Then lastly, solving for A. You've got the A's already together, so this one's consolidated the A's for us. And then factor it out like we did in the last one. It's a little bit easier because it had some of our work started for us. Divide by what's in that parenthesis. And there you've got it. So kind of the principles for solving all of these is number 1, clear any fractions. Then number 2, collect the variable you're asked to solve for and throw everything else to the other side. If you can't combine those variables, then you have to factor the variables and then divide by what's your variable. All right, let me know if you need any further help on any of those.